Welcome back, everybody. Today we are going to be talking about subtraction, which the idea of subtraction is taking away numbers. So, let's start with some magnets again here, okay? Let's say I have 3 magnets there, which I will denote right above it by the number 3. We have 3 magnets. I'm deciding I'm going to take away minus 2 of them. How many am I going to have left? Well, I'm going to take 2 magnets away. How many am I going to have left? I'll have only 1 left. That's one example with magnets. Now let's do this with all of them that I have. I'll use all 12 magnets that I have. Just got to slide them into place. Alright, so if we count them, I should have 12 magnets. I got 12. I'm going to take away, which is minus, I'm going to subtract 6 of them. Let's move the 6 of them out of the way. I took away 6, so 12 minus 6, how many do I have left? We count what I have left, well, we should get 6. 12 minus 6 is 6. Alright, well that's some examples with objects, practical everyday examples. You're also probably asking, why would I want to subtract numbers? Well, a big real world application is balancing your checkbook. When you're going, like when you go to the store, when you pay your bills, how much money do you have left in your bank account from, let's say you start with $1,000. You spent $350 on your utility bill, another $200 in groceries. And then you got to pay a phone bill, which is probably another $100. How much money are you going to have left after you pay all those? That's just an example. But another way of doing subtraction is also a number line. Just like addition, we can also use number lines. Oh, how about 89, 88, 87, 86, 85, 84, 83, 82, 81, 80, 79, 78. Okay, I've got me a handy dandy number line here. Let's say I decide I'm going to start at the digit 89. That's going to be my start point, 89. Alright? When I subtract numbers, I go backwards. So addition, you're going this way. In subtraction, you're going that way. You're going to the left. So let's write my starting number here, which is, I get this, there we go. My starting number is 89. I want to know what value I'm going to have if I subtract 11. If I take away 11, if I subtract it, where will I end up? Well, again, like addition, you're going to count on the number line, but with subtraction, you're going backwards. So let's see, you start at 89, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 will put me at 78 if I went backwards. So that would be the result of that. Let's do one more. Let's say see 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13. Okay, let's say I start with the number 20. Yeah, just 20. How about that? I'll start at 20. That'll be my starting number. So, I was given 20 to start with, and I want to go backwards 6 places. Well, what I need to do is go ahead and count them. So I started at 20. I got 1, 2, 3, 4, 5, 6. Well, if I go backwards 6 spaces, I ended up with 14. If I get this to cooperate, there we go. 20 minus 6 is in fact 14. And I'll go ahead and put my dot there to signify that. So number lines are very useful tools if you're not quite sure. If you struggle a bit with mental math, like adding numbers in your head, that's okay. You can use number lines, you can use objects, you can count. That is not a problem. Now, I'm going to teach you a couple rules that are going to make your life a lot easier with subtraction. One rule is if I take any number, we're going to call that number A, any number minus 0, I should get that exact same number back. Kind of like addition. If I have any number and I add 0 to it, I get the same number back. Well, if I have a number subtract 0, I get the same number back because I've taken nothing away. So, how about 5 minus 0? I took nothing away from it. I should get 5. How about 187 minus 0? Again, I took nothing away from 187. I should get back 187. Alright, that's easy enough. I think we get that subtracting 0 gives you the same number back. Another good useful piece of information is if I take any arbitrary number and I subtract that same arbitrary number from itself, I'm going to get 0. So another example, let's take 5. We'll subtract it from itself. 5 minus 5. That should give you 0. Also, I have 187. I subtract 187 from itself. I should get 0. So yes, any number minus itself will in fact give you 0. Alright. Let's see here. Now we need to do some subtraction problems. We're going to do it the longer subtraction way. We'll start with easy enough ones here though. You will also see subtraction problems written this way, kind of like you did with addition, only it's subtraction. So I have the problem 16 minus 4. I'm taking 4 away from 16. Just like with addition, you always start in your ones place. Start with the rightmost set of numbers. So 6 minus 4 is 2. Alright, that's a 0 in front of the 4, so 1 minus 0 is 1. That should give us an answer of 12. Easy enough, right? You start with the right, work your way to the left. Okay. Let me erase that problem from the list of problems I'm going to teach. How about take it up a little bit. We'll do 65 minus 21. Alright, so we got 65 minus 21. Again, we start with the rightmost set of numbers. So we'll do 5 minus 1 is 4. Then we work our way over. 6 minus 2 is 4. So we would get 44 as our answer. Not so bad so far, right? Okay. I think it's time we take this up another notch. Let's do 86 minus 47. Well, we start with the ones place. Immediately, we notice something. We can't do 6 minus 7. It doesn't work. However, what we can do, we can make this a 16. Write with blue ink. We make that 6 a 16, but that means we have to borrow 1 from the next place over. We borrow 1, that becomes a 7. Now we can do 16 minus 7, that's 9. 7 minus 4 is 3. So the answer to that is 39. I'll do another type of problem like that with borrowing. Let's say we have, 981 minus 747. Well, immediately, again, we notice we have a problem when we start in the first digit, first set of digits. We can't do 1 minus 7. That simply doesn't work. What we have to do is make that 1 into an 11. That 1 becomes an 11. We have to borrow 1 from the next place over, from the 8s. That becomes a 7. So we have 11 minus 7 is 4. 7 minus 4 is 3. The 9s was unaffected in the hundreds place, so 9 minus 7 is 2. Your answer would be 234. Okay. One of my biggest pet peeves is when the teacher did not completely erase the board. I don't know about you, but I was OCD about that a little bit. So I try not to be that teacher. Okay. We have 3,982 minus 2,489. So immediately we notice we have 2 minus 9 on the right. Again, doesn't work. We can't do 2 minus 9. We have to make that a 12. Which means we got to borrow 1 from the tens place, make that 8 a 7. So 12 minus 9 is 3. So far so good, right? Well, I just noticed another problem. We have 7 minus 8. We also can't do that. So we're going to have to make that 7 a 17, and we'll have to borrow 1 from that 9, make that 9 an 8. So 17 minus 8 is 9. 8 minus 4 is 4. 3 minus 2 is 1. So your answer would be 1,493. That's your answer for that. Okay, we got another problem here. 7,640 minus 3,809. Well, we notice we have 0 minus 9 to start with over here at the right. That's not going to work, is it? Drop my marker cap. My dog almost got it. Don't want the dog to swallow marker cap. Okay, so we got that 0 has to become a 10, which means we got to borrow 1 from that 4, which would be a 3. Borrowing 1 from the next place over. Now we can do 10 minus 9, which is 1. We can do 3 minus 0, which is 3. Until we get to the hundreds place to start subtracting. We have 6 minus 8. That simply isn't going to work. We need to make that 6 a 16, which means we got to borrow 1 from that 7, which would make that a 6. 16 minus 8 is 8. 6 minus 3 is 3. So your answer is 3,831. Alright. One more easier problem, then I'm going to take it up another notch. This one won't be bad at all. just 80 minus 24. Okay, 80 minus 24. Again, you start with the rightmost number. These here, you have 0 minus 4, doesn't work. So you're going to have to make that 0 a 10. You'll have to borrow 1 from the next place over, which will make that a 7. That 8 becomes a 7 then. So we got 10 minus 4 we can do. 10 minus 4 is 6. 7 minus 2 is 5. Your answer is 56. Alright. I got 3 more problems here, and then we'll be done with the lesson. I like to take my time with subtraction because to some people, and when I first learned it, it was too, borrowing digits from places to subtract numbers was a bit confusing even for me at first. So if it's confusing, don't feel bad. You're not alone. I fell into that trap when I first learned it myself. So okay, we start the right. This time we actually have a number we can work with on the right. 8 minus 8 is 0. However, we get to the tens place, we have 0 minus 5. Doesn't work. We're going to have to take that 0, make that a 10, which means we got to borrow 1 from the next place over, make that 4 or 3. What is 10 minus 5? Well, that's 5. What is 3 minus 2? Well, that's going to be 1. 6 minus 0, that is 6. So your answer is 6,150. Okay, a couple of harder problems. I got 2 more. They're harder than what we've done yet, but I know we can do them. Let's say we got something like 7,000 minus 2,794. 2,794. Okay. Immediately, it looks like none of these are going to work because you have 0 minus 4, 0 minus 9, 0 minus 7, 7 minus 2. Well, there's a way we deal with that. Again, start the right. The 0 minus 4 doesn't work. I'm going to have to make that a 10. That 0 should become a 10. The only problem is we go to the next place to borrow, we have a 0. Well, let's make that 0 a 10 also. If we're going to borrow from 10 to make that a 10, that actually becomes 9. So, starting again, 0 minus 4, we have to make that 0 a 10. We go to the next place to borrow. We have a 0 also. We have to make that a 10. We're borrowing 1 from 10, that's a 9. But in order to make that work, we have to borrow 1 from the hundreds place, from the 0 there. Well, that 0 would also have to be a 10. In order to make this a 10, we'd have to make that a 9 also. But in order to have made this a 10 in the first place, we would have had to borrow 1 from the thousands place, which would make that a 6. Okay. So we have 10 minus 4 is 6. That works. Now we have 9 minus 9. That's 0. 9 minus 7 is 2. 6 minus 2 is 4. Your answer should be 4,206. And yes, don't worry, I have other examples. I do have other examples of that. The type of problem I just did is about as hard as subtraction can get. You can get through that, you got it. And I have no doubt you can get through it. There's no doubt in my mind. Let's do 1,000 minus 783. Again, we have a bunch of zeros that just don't seem to work. So 0 minus 3 doesn't work. We're going to have to make that 0 a 10. Well, we have a 0 next to it. It's kind of hard to borrow from a 0. You would have to make that a 10. You can borrow from 10, which would make that 9. But then I run to the problem of if I'm going to make this 0 a 10 to begin with, I'm going to have to borrow 1 from this 0. Well, I'd have to make that a 10 because you can't do 0 minus 7. You make that a 10, you borrow 1 from that. That's a 9. Now, in order to have made this a 10 in the first place, I have to borrow 1 from here, from the 1. That's 0. So, if you can do, see, you got 10 minus 3 is 7. 9 minus 8 is 1. 9 minus 7 is 2. 0 minus 0 is 0. So your answer is in its lowest form, which is going to be 217. All right, how about, you know, I said that we'd only had to do a few more, but how about 2,532 minus 1,999. Let's do that. Because sometimes the harder addition problems also will occur that are not zeros. So we start the right, we notice we have 2 minus 9. Doesn't work. We're going to have to make that a 12, which means we got to borrow 1 from the 3, makes that a 2. Alright, so 12 minus 3 is in fact 9. So 12 minus 9 is 3. Then we have 2 minus 9, doesn't work. We're going to have to make that a 12 and borrow 1 from that 5 there, which would make that a 4. 12 minus 9 is 3. Then we got 4 minus 9. Well, that sure isn't working either, is it? We're going to have to make that a 14, which means we got to borrow 1 from that 2, makes that a 1. So what's 14 minus 9? Well, that's 5. And then we got 1 minus 1 is 0, so your answer would be 533. That wasn't too bad of a problem. Let's do a couple more here, like 2 more. If you want to know my age, this is your chance. I was born in the year 1987. The current year is 2024, right? That's our current year. I was born in the year 1987. So we subtract 1,987 from 2024, we'll get my age. So we start with 4 minus 7, doesn't work. If you start with the right, 4 minus 7, that's got to become a 14. We'll have to borrow 1 from that 2 there, that becomes a 1. So what's 14 minus 7? 7. What is 1? Well, 1 minus 8 doesn't work. That does not work. So we got to make that an 11. Well, we can't really borrow from a 0. We'd have to have had that being a 10 all along. We borrow 1 from a 10, that's a 9. But in order for this to have been a 10 in the first place, we have to borrow 1 from the 2. So we have 11 minus 8 is 3. What is 9 minus 9? 0. What is 1 minus 1? 0. So at this current time, I am 37 years old. Well, Matt, you may be asking, well, Matt, how old were you in 2000? I can answer that also. In the year 2000, back when Y2K was big, because I was born in 1987, we're going to subtract that from it. Okay. I have 0 minus 7, which does not work. I have to make that a 10. But of course I have to borrow from the next place. I can't do 0 minus 8. That would have had to have been a 10 minus 8 all along. Now I can borrow from 10. I can't borrow from 0. I can borrow from 10, which would, by borrow 1 from that, makes it a 9. But in order for that to have been a 10, I would have had to borrow from the hundreds place. 0 minus 9 doesn't work. If that were a 10, I could borrow from it, which would also make that a 9. But in order to have made this a 10, I would also have had to borrow from the 2. Borrow 1 from that, you have 1 minus 1. So now I have 10 minus 7, which is 3. 9 minus 8 is 1. 9 minus 9 is 0. 1 minus 1 is 0. So in the year 2000, I would have been 13 years old. Back in my wild and crazy teen years. Yay. Okay. So that does conclude this lesson for subtracting. Oh, not quite yet, actually. Let's say I had 2000 minus 1987. We know we got 13. Well, what you can do with that, right beside it, if you take the answer and the smaller number and add them together, you should get the bigger number. What do I mean by that? I take that 1987 plus 13, right? So I'm taking the answer and that smaller number together. 7 plus 3 is 10. Carry that 1. 1 plus 8 is 9 plus 1 is 10. 1 plus 9 is 10. 1 plus 1 is 2. You should get the bigger number back. That's how you can check your work in addition. Check your work with subtraction and turn it into an addition problem. Oh, one more. We'll do a check and then we'll... So, let's see. It's the year 2024. My dad was born in 1961. That's going to be his current age. So 4 minus 1 is 3. 2 minus 6 doesn't work. That'd have to be 12. Well, we can't borrow from 0, but we can borrow from 10, which we borrow from 10. That makes that a 9. In order for this to have been a 10 in the first place, we'll have to borrow 1 from the 2. So 12 minus 6 is 6. 9 minus 9 is 0. 1 minus 1 is 0. So my dad is currently 63 years old. Yes, he's even gotten all the AARP stuff, if you're wondering. Okay. No offense to anyone who's on AARP. Just thought I'd drop a little humor in there. Anyway, what was I saying? Oh, yeah. 2024 minus 1961. He's 63, we determined. If I take 1961, that smaller number, plus the answer, I should get 2024 back. Well, 1 plus 3 is 4. 6 plus 6 is 12. You have 2, you carry the 1. 1 plus 9 is 10. You have a 0. 1 plus 1 is 2. Voila. In fact, it is the year 2024. That's a way to check your addition. The answer plus the smaller number should equal the bigger number. So if you're ever unsure and can't use a calculator or don't have access to one, that's a way to check it. But that does conclude this lesson. Next lesson, we will talk about rounding and estimating numbers. And I will see you on the next lesson.